Good day, everyone. Welcome to class 4 of our cybersecurity series. Today, we're going to talk about networking. And our learning objective today is that at the end of this course, you should know basic network types and how devices communicate. You should be able to explain IP addressing, subnetting, and identify different classes of network. Recognize key network protocol like TCP, UDP, and ICMP. Understand the structure of packet and how data flow through the OSI module. Use basic Linux networking tools to inspect interface and diagnose connectivity. So what are network? Network can simply be defined as the internet connection of computers system in order to share resources, files over the internet. Networks are classified by their scale and scope. One of it is the LAN network. The LAN network is basically network that is in your office or school. That means it covers small geographical area like your home. Devices are typically connected by Ethernet or Wi-Fi. So if you have a Wi-Fi network in your house, that's a typical example of a LAN network. So example of the LAN network are home Wi-Fi router connecting your phone, laptop, and printer together. We have the wide area network. Wide area network covers large geographical area. The internet is the largest example of one. So I talked about the internet. The internet is the interconnection of devices over the globe. And then the people that provide this wide area network can be the ISP like MTN, Glo, Starlink, or the rest. So device may connect over leased line, satellite, or cellular network, just like the MTN, the Airtel, and the rest. The satellite network can be the Starlink. We have the personal area network. Personal area network is a very short range network, usually few meters, used for device-to-device connection, like the Bluetooth, the US tethering. Example are connecting a phone to a wireless headset. What is IP addressing? In networking, devices are identified by their IP address. In fact, IP address can otherwise be known as the address of each of the system over the network. So just like your home address, whereby if a delivery agent wants to deliver a mail, let's say someone is delivering a mail from USA to Nigeria. First, the mail has to come into Africa as a continent. Maybe to the nearest head office in Africa. Then it needs to get to the nearest head office in Nigeria. Then from Nigeria, we need to know which states would this mail go to. Then let's say the mail is being directed to Akwa Ibom State. It needs to look at the nearest post office in Akwa Ibom State, and let's say their head office. And then from their head office, it will be distributed to the local government, because each local government should have a post office. Then from the local government, we can look at the address of maybe the village or the town, or even the territory that the recipient is living. So same thing with IP address. It helps each and every system connected to the network to be identified. So an IP address is a unique identifier for a device on a network. It can be IPv4, which is what 32-bit address. Each of these address is 8 bits. So 192 is represented in 8 bits, 168 represented in 8 bits, 1 represented in 8 bits, and 1 represented in 8 bits. So 8 plus 8, 16, 16 plus 16, that is 82. So we have another one because with the introduction of IoT devices and the rest of the devices on the internet, a lot of devices are taking up IPv4, and IPv4 is kind of going to be exhausted. So that's when the idea of IPv6 came in. IPv6, to some certain extent, theoretically, it can't be exhausted because it's around 128 bits. And so many devices have to take up these addresses before it is being exhausted. And I don't think it will be exhausted. In fact, this is the best and it's the future IP address. So the IPv6 is what? Is 128 bits. So we have IPv4 classes. So we have class A, class B, and class C. Then class A covers range from 1.0.0.0 to 126.255.255.255. The subnet is 255.0.0.0. So it's a large network. So this network is basically used in the WAN because it gives room for a lot of hosts. Then the B class is from 128.0.0.0 to 191.255.255.255. And then this is a medium network. So that's a subnet of 255.255.0.0. Then the C network is basically a smaller network. Basically the network we use in most of our LAN offices and the rest. So it covers from 192.0.0.0 to 223.255.255.255, and then the subnet. And then we can see that the use case is smaller network. So subnetting divide a network into smaller segments. It helps organize devices logically, reduce broadcasting traffic. So instead of a device wasting its time to broadcast a traffic to every host, this is what we call VLAN, virtual LAN. That means even with a managed switch, some devices can also be segmented into a smaller kind of network range or network subnet. Let me put it that way. So when a device in that subnet is broadcasting to almost all the devices in that subnet. So instead of it to broadcast to the whole switch, it knows that this IP address should be within this subnet. So it helps reduce broadcasting traffic. Then support security zoning. So example, this network 192.168.1.0 is in subnets 255.255.255.0. So host-based subnet is about 254 usable IPs. So with this subnet, we're going to have about 254 hosts. So we have some common protocol. Protocol are just a kind of, let's say, a rule that every device connected to the network has to follow in order to transmit or share resources over the network. So we have so many devices and we have so many brand of devices, the HP, the Dell, the Motorola and the rest, Apple laptops and the rest. But this device has to follow some protocol, some rules in order to do what? To transmit data over the internet or over a LAN network. So one of the protocol is the TCP, Transmission Control Protocol, which is a very reliable connection-oriented protocol that ensures that data reaches its destination. It has some error check and packet synchronizing, and then uses something like HTTP, HTTPS, FTP, and SSH. Compared to user datagram is unreliable, connectionless. Basically, UDP is mostly used to transmit videos, like your YouTube videos, streaming videos, and the rest. So faster than TCP because there is no three-way handshake. So that's why it's more faster, and data are much when they are transmitted, unlike the TCP that has to break the data into smaller packets. So faster than TCP, but no delivery guarantee. So used by DNS, streaming, and voice over IP. So ICMP, which is the Internet Control Messaging Protocol, this is a kind of the protocol that controls diagnostic tools like Ping, the Traceroute. Ping is used to know if a device is active or if it's actually reachable. Then Traceroute counts the number of hops or the number of router this traffic will go through before meeting that particular device or the destination device. So ICMP ensure that communication network level errors and reachability. OSI model and packet structure. So the OSI model is the conceptual framework that describes how data moves across network. Layer 7 is the application layer, and it uses some things like HTTP, DNS, FTP, etc. HTTP is actually hypertext transfer protocol. Is a protocol used to transmit data over the internet, like the web server and the client. DNS is a server that responds to queries pertaining to domain name resolution. FTP is actually used to transmit files over the internet. So application layer has to deal with the layer that is close to the user. We can use the web browser as an application layer, that is the Firefox or the Chrome. Then we have the presentation layer. Presentation layer deals with encoding, compression, and encryption. So another layer is the session layer, which deals with session creation and management. Things like session management, which has to know if a connection is still active or if it is closed, because the client and the server are always communicating to ensure that the data that is being transmitted is not cut off. So this layer actually manage such. Transport layer ensure that data are being delivered. In the transport layer, we have protocol like TCP or the UDP. If we talk about that, they are the transport control protocol and the user datagram protocol. We say that the TCP is end-to-end oriented. It ensures that data is being delivered. Check for errors, unlike the UDP, which transmit a lot of data and is more faster than TCP, but it's never concerned with whether a data is being delivered to a destination. So the network layer has to do with IP and routing. So it actually assigns IP addresses to any data that is going out of the system, and then it knows the best route to reach that destination. Data link has to do with the MAC addresses and the Ethernet. So every devices have a MAC address and a unique one at that. Every devices across the network have a unique MAC address that is not shareable. So unless in the pen lab, maybe it can be changed when you are doing your penetration testing. But in real sense, this is hard-coded. It can't be changed. And then the physical layer has to do with the cables, the fiber optics, and the Wi-Fi, if at all is using the Wi-Fi network to transmit the data. So for the cable, we have something like the Cat6, the Cat5, and the rest. Fiber optics cable, this is the most fastest and reliable connection now. So the packet structure, we have the IPv4 packets contain the header and the payload. So the header contains what? The source destination IP, the protocol, the TLS, which is deals with the security, and then the payload is the actual data which is being transferred. So that has brought us to the end of this course. We are just going to go over to our lab and try to use some tools, some network inspection tools. Let's move over to our Kali Linux lab. Welcome to our Kali Linux system. Here we're going to show our network IP address. Then we try to reach the Google server and see if our system can reach there. We use Traceroute to know the hop or the path it takes to reach Google server. So first, let's use ifconfig to know our IP address. So you can see these are basically an address from VirtualBox. So if you check very well, you see our interface etc0. etc0 is actually the interface I'm using on my Linux system. So this is the IP address of my system: 10.111.213.19. Then I am on this subnet 255.255.255.0. So this is my IPv6 address, and this is my MAC address 08.00 colon 27 colon FE colon D4 and the rest colon 12. So that's how you know that this is my MAC address. So that's how to basically check IP address, which is IPv4, IPv6, and the MAC address as well. So this one is the loopback address, which is the IP address of the local system. You can also check the IP address of the system using IP address show. So IP address show. This also gives us a lot of information about the network configuration of our system. So you can see same thing, IPv4 on this interface is giving me this IP address 10.111.213.19 telling me that it's in subnet 255.255.255.0. So the IPv6 address is being given here as well. Then this is the MAC address given here as well. All this is the broadcasting address. So I haven't checked that. I can check the default router, or call it a gateway of my system. So you can see from my system now, default all outgoing traffic is pointed to this gateway 10.111.213.70, and this is my IP address 10.111.213.19. Then you can see this is IP address of my network on this interface, and then the rest, the IP address of my Docker. I've installed Docker, and this is my device. Then, so that's how to basically check your default gateway or router that your system is routing to. Then we can try a ping tool. Try the ping tool. Okay, so I'm going to ping my vulnerable server. Let's check the IP address of that vulnerable server. We can use ifconfig to check the IP address, and we can see that the IP address is at 10.111.231.142. So let's get back to our system. Then let's ping 10.111.2.111.23.111.23.142. Let me just confirm if it's so. .231.142 213, I guess 213. So you can actually ping that. So you can see that we have pinged this vulnerable server, and we sent 5 packets, and 5 packets we receive and 0 packets we lost at this time. So it means we can actually reach this server. So the server is live. You can use Traceroute to also try to check the path it takes to reach that server. So 10.111.2.213.142. So we can see that it takes only one path. So that is basically how you can ping a target. It doesn't have to be an IP address. You can ping Google. Right now, my system network configuration on my VM is not connected to the internet, and it could have been used to ping Google. So if you want to ping Google, you can reach out. You can ping Google. You can see that me pinging Google, I have the Google IP address, but for some reasons, my network configuration on VM is down right now. So because of what I used the VM to do. So you can actually ping, a site, not only an IP address. They can also trace route to a site as well. So that has brought us to the end of this video. And okay, you can see that 26 packets have been transmitted and 0 is received. That means we have not, we cannot establish a connection with google.com. So if I go to my browser and try to reach Google, it won't be reachable. It will be a client error issue. So that is how you can use Ping to, try to diagnose some network issues and the rest. We have come to the end of this class, and thank you for staying up to this moment. Hope to see you in our other series.